guys, we are continuing with Unit 7 exponential functions today. Your test is Friday. So there's a foldable quiz on Thursday and a test on Friday. Okay, so let's go ahead and start with this sheet right here, the one that says exponential unit day 5. And if you will write down just this, y equals ab to the x power. If you will write that down where you have some space, y equals ab to the x power. Okay, I had to redo your foldable sheet because my formula wasn't mathematically accurate after I did some work with it this weekend, so want to make sure that it's very understandable. Does A have the X with it? No. So just like in linear, that makes it the starting value. So how about making sure you have starting value with the A? Feel free to abbreviate. Put starting value with the A. A is your starting value. You can abbreviate. All right. Sometimes for the B, we just plug in a number, and we're going to talk about this in a minute. Sometimes for B, we just plug in a number. Other times, if it has a rate, like let's say it's 8%, then you have to do 1 plus R in that spot, or you have to do 1 minus R in that spot. And we're going to talk about that in a minute. Okay? So sometimes B is just a plain old number. Sometimes it's 1 plus R we have to use, and sometimes it's 1 minus R. And we will talk about that. Okay. All right. One more thing. For exponentials, there is a starting value, but there's not a rate of change because it's not changing by the same thing every time. And we talked about that on Friday, but I want to make it a little more clear. Okay, so there is a starting value. What's the other word for starting value? Y-intercept. So that's optional. You could write that down if you wanted, but starting value and y-intercept will be the same thing. Okay. All right. Let's, you don't have to write this down. Let's just refresh. What's the formula for linear? Y equals mx plus b. And which one of those is the starting value? The B, because it doesn't have the X. Okay, so that's your starting value, and M is your what? Slope. There is no slope for exponentials. There's no slope or rate of change. Okay? Okay, now we are going to jump to this sheet. Okay, we're going to jump to this sheet. Okay, so here's an example. Julie is trying to win a hot dog eating contest next month. Right now, she can eat 4 hot dogs in one sitting. To train, she's going to eat 2 more hot dogs each day. So first of all, why is this linear? Because she's eating 2 more hot dogs. If she is staying the same, every day she's going to eat 2. That's a constant rate. That's a constant rate. So that makes it linear. Okay, so that's the first thing I want you to understand. It's constant. That's what makes it linear. All right. For my function rule, that's going to be a y equals. What's one thing that needs to go in the function rule? 2. Okay, she's eating 2 more hot dogs each day. So how do I write that? 2x. Okay. What else needs to go in the function rule? Yep. So I put what? Plus 4. Okay. All right. What's the starting value right here? 4. And what is the rate of change? 2. It's always going to be 2. She's going to eat 2 more hot dogs tomorrow. She's going to eat 2 more hot dogs on Wednesday. She's going to eat 2 more hot dogs on Thursday. She's going to eat 2 more hot dogs on Friday. The rate of change is constant. Rate of change is constant. Okay, so let's make a quick table. So let's put, she starts out consuming 4 hot dogs. And you have to be careful. That's the starting value. What number always goes with the starting value? 0. Good. Not 1, but 0. Because remember, that's the same thing as the y-intercept. So it always has to have a 0 with it. So 0 and 4. All right. On the next day, she's eating 2 more hot dogs. So that is 6. And then the next day would be 8. And the next day would be 10. Okay. Just to drive my point home, because I really want y'all to understand this. From 4 to 6, it went up 2. From 6 to 8, it went up. And from 8 to 10, it went up 2. That makes it linear. That makes it linear. It's going up the same amount every time. Okay? All right, if we wanted to put this on a graph, you start with the starting value. So I'm starting with 4. 1, 2, 3, 4. So I'm putting a point at 4. And then I'm doing what? Up to and over 1. Very good. You can put a 1 underneath it. Up to and over 1. And it makes a straight line because it's linear. Okay? All right. Do we understand that example? Okay. Any questions on that one? Okay. Now, an exponential example. Jack invested $500 at a yearly interest rate of 8%. Okay, so it is a percent, so that's going to make it exponential. So the first thing that goes in exponential is your starting value. That's what you always put first. So how much is he starting with? 500. So you put a 500 right there. In exponential, we don't put a plus or a minus. We put a parentheses. For exponential, we put a parentheses next. And if it has a percent, you have to use the extra little rule here if it has a percent. Okay, you have to do 1 plus R or 1 minus R. So he's earning 8% interest. Is that adding to his account or taking away? Adding. So you're going to put 1 plus. You have to do that whenever it's a percent. You have to put the 1 in there. And we have to move the decimal 2 places. So that makes it 0.08. And we're going to do more of those today. I know that I'm kind of talking quickly. So you get 1 plus 0.08 to the x power. X goes in the exponent spot. Why does x go up high? Because it's exponential. So x has to go in the exponent. Okay, so my starting value is what? 500. 500 is my starting value, the one without the x. Okay, the rate of change is not constant, so we cannot put a number there. We cannot put a number. Here's the only thing we can put. Is my money going to increase every time or decrease every time? Increase. So the rate of change is increasing. It's not a number because it's not constant. The rate of change is increasing. The rate of change is increasing. Okay, so let's put 500 in for his first amount. So what number has to go with 500? 0, because it's your starting value. Where can we put that in our calculator to help us make a table? In y equals. Everybody go to your y equals. That'd be good practice for us. Go to your y equals 500 parentheses 1 plus 0.08 to the x power. 500, 1 plus 0.08 to the x power. All right, and then you go to second graph, so you can look at your table. Second graph, and you've got a table in there, so I'm going to go back down to 0, 500. All right, what goes in for year 1? How much money does he have? 540. What about for year 2? 583.2. And the third year? Okay, so look, from 500 to 540 is how much? 40. How much is it from 540 to 583? Very good. 43.2. And what about that last one? Approximately what? What's that approximately going to be? What do you get when you subtract those? $46. Okay, you get 46. Is the rate of change constant? No, because it's not linear. What's happening to my rate of change? What's it doing every time? It's increasing. So there is not a number for the rate of change because it's increasing every time. Okay? All right, we're going to make a quick sketch of the graph. We're actually going to learn how to graph them tomorrow. So if you don't understand what I'm doing, it's fine. What was the y-intercept, though? 500. Very good. So I'm just going to put a point at 500. Doesn't have to be super accurate. Put a point at 500. Is his money going up or going down? It's going up, and it's exponential, so it makes a curve. It makes a curve, and it's going up. Exponential makes a curve. Okay. All right, we'll do more with that. Okay. All right, the next example. Eagles are an endangered species. There are only 100 left in the wild, and a half disappear each year due to poaching. What is my function rule? All right, so this one's exponential. We'll talk about why it is in a minute. So y equals, what do I put after the y equals? Good. Why am I putting 100? It's my starting value. This time, I don't use the 1 plus r or the 1 minus r. Is there a percent on this one? No. This one, you're just multiplying by what number? You're just multiplying by half, and you put the x up there. You only have to do 1 plus r or 1 minus r when there's a percent. All right, so what's my starting value? 100. There is no rate of change. Is it increasing or decreasing? Decreasing. We'll talk about that in a minute. It'll make more sense when we actually look at the table. Okay, so I'm going to put 100 for the Eagles. What has to go with the starting value? 0. Okay, so what's 100 times a half? 50. What's 50 times a half? And what's 25 times a half? Okay, so let's do the rate of, or let's see what's happening here. 100 to 50. It's losing 50. Okay, always put what it's adding or subtracting. What about here? 50 to 25. And then 25 to 12.5. So what's happening here? It is decreasing. Okay? All right, and the last little part, we'll do a graph. All right, what's my y-intercept? 100. And what's happening to the Eagles? They're decreasing. It's going to be a curve because it's exponential. So it looks like that. Okay. Okay, we're going to do more with this today and tomorrow. I just wanted to try to give you like an overview before we went into smaller stuff. Okay, so now we're going back to this other handout. We're going to knock it out real quick. For each situation, write a function rule and a now next rule. So by a function rule, it means a y equals. So on number 1, we're going to make a y equals. What is my starting value? 3,000, so I put that next. It has a percent, that means I use parentheses. Percent means I use parentheses. I also have to put a 1. Whenever I see a percent, I've got to put a 1. And you have to decide, is your money increasing or decreasing? And I didn't word that one very well. It should say you made $3,000 last summer and you put it in the bank at 6%. So I need to go back and fix that one. But your money is doing what? Increasing or decreasing? Increasing, so you put a plus. And then you have to move your decimal 2 places. And you put a 0 in the empty spot. So 0.06 to the x. Okay. All right, let's go ahead and make that look like it's going to look on the test. So that's going to be y equals 3,000. What is 1 plus 0.06? 1.06. So that's how it's going to look on the test. They're not going to have the plus in the final answer. They're going to go ahead and combine them together. Okay? All right, ladies and gentlemen, now we're going to do the now next rule. These are new. We've always had those in multiple choice, but now we're actually going to write one out. You always start with the word next. So write that. Next equals. That's how they always start. They always start with next equals. They actually always start with next equals now. So go ahead. It always starts with those 3 things. Next equals now. That's how it always starts. So let's say right now I have $3,000. That's what I have right now. What am I doing with this? Am I adding it or multiplying it? I'm multiplying it by 1.06. So that's all you have to do. Next equals now times 1.06. So that's all you have to do for a next equals now rule. Okay, number 2, we're going to put a y equals. Jack, what goes first after my y equals? 20,000. Riley M., for a percent, what do I have to write next? Uh-huh. Very good. You have to put a 1 in there, parentheses 1. Elijah, for depreciates, do I put a plus or a minus? A minus. Very good. Guys, depreciates means it's going down. Stephen R., how many times do I have to move my decimal? Twice. Very good. So that gives you 0.09, and you put x in the exponent spot. Put x in the exponent. All right, guys, we need to go ahead and subtract those. You type that in your calculator, just 1 minus 0.09. You're just typing in that little bit in your calculator. So it's going to be y equals 20,000. What do you get when you subtract those 2 numbers? 0.91 to the x. So you do have to do that one step. All right, Brandon. How do I do this now next rule? What do I write? Next equals now. That's the order you always have to put it in. Next equals now. And Faith, what am I doing with the 20,000? Am I adding it or multiplying it? Multiplying it by what? 0.91. I'm multiplying it by 0.91. Raise your hand if you have a question. Okay. Number 3, you bought a rare baseball card for $7,500. It appreciates 4% in value each year. Jeremy, what's my starting value? So that goes first. Hallie, what am I going to put next? Parentheses 1, and then what? Plus or minus? Yep. Guys, appreciates means it goes up. Appreciates means it goes up. So you put a plus. Stephen A., how do I do 4%? How do I write that? Very good. 0.04, and the x goes up high. All right. All right, Chase, go ahead and simplify that for me. What is it going to look like? Very good. All right. Samaria, help me with the now next rule. What do I write? Times 1.04. Very good. Number 4, you invested $5,500 in the stock market. You lost 12% each year. Drew, help me with this one. Keep going. Yep, to the x power. Zach, what is that going to look like when you simplify it? Good. And Shakira, help me with the now next drill. Very good. Number 5, Rural Hall has 57,000 citizens. The population is increasing exponentially by 3.5% each year. Madison, help me with this one. All right, sorry about that. You have 85,000 or 850,000? Okay, yep, sorry about that. Okay, keep going, Madison. How many times do I move it? 2. So it's going to be point what? There you go, 0.035 to the x. All right, Riley K., what does it look like when you simplify that? All right. Madison, help me with my now next rule. Very good. All right, number 6, Mrs. Williams bought a house for $50,000 and it doubles in value each year. All right, guys, put your pencils down real quick. Put your pencils down. This one, y equals, what's my starting value? Don't pick them up yet. Don't pick up your pencils. Is there a percent in this one? No. What does doubles mean? Times 2. I'm not putting in a 1 plus or a 1 minus. You only do that for percents. Doubles just means to times by 2. What does parentheses 2 mean to do? Multiply by 2. Okay, you can pick your pencils up. So that's all you have to do on that one. That's all you have to do. Okay. All right, Riley M., what do you think my now next rule is going to look like? Very good. Times 2. Okay. All right, number 7, the initial population of 50,000 fell each year by half as people moved out of the city. All right, Stephen R., what's my starting value? On number 7? So I've got 50,000 people. Zach, what's happening to the 50,000 people? You're multiplying by half on this one. You're multiplying by half. Half of them are disappearing. Multiplying by half. All right, Faith, help me out with the now next rule. Questions? All right. Describe the starting value and the increasing, decreasing nature of the following exponential functions, okay? So we'll start with A. What's the starting value? 200. So the starting value is 200. Okay, 0.93. Is that less than 1 or bigger than 1? Less than 1. Does that mean that it's going to be increasing or decreasing as you multiply by it? It's going to decrease it. So if this number is less than 1, it makes it decrease. It makes it go down. Okay? Now, this one we're kind of working backwards on. We have to figure out what percent could have been in the original, bless you. We got to figure out what percent could have been in the original problem to get to this. Okay, so what you're going to do in your calculator is you're going to do 1 minus 0.93, and it gives you 0.07. What would that have been as a percent in the original problem? 7%. So in the original problem, there would have been a 7% in the original problem. Somewhere there would have been a 7%. Okay, on the next one, for B, which one of these is my starting value? 750. That's my starting value. 1.15, is that bigger than 1 or less than 1? Bigger. So as you multiply by that number, do you go up or does it go down? It goes up. So this one goes up. We need to figure out what percent it originally had. That one's pretty easy, but let's just show people in the calculator. 1 minus 1.15. What would that have been as a percent? 15%. Don't worry about the positives or negatives, because we know it's going up. Okay, so it just depends on what order you type it in your calculator, what it gives you. All right, the next one, C, Riley K. Which one's my starting value? 6,000. Drew, is this one increasing or decreasing? Increasing, because it's bigger than 1. Samaria, what percent would have been in the original problem? 4%. Very good. All right, D, Stephen A., what's my starting value? 30. Elijah, is this one going to be increasing or decreasing? Very good, because it's less than 1. All right, Brandon, what is it? What percent would have been in the original? Very good. So you have to do 1 minus that, and he got 15%. Good. All right, Shakira, what's my starting value on this one? Hey guys, everybody look up here real quick. I got to tell you something about this one. That one, there wouldn't have been a percent in the original problem. There would have not been a percent in the original problem. What are they doing here? They're timesing by 3. What's a way you could say that in math, to times by 3? Starts with a T. Give me a T. Give me an R. Give me an I. Somebody said it. Triples. All right. For this one, in the original problem, they probably would have used the word triples. Okay? Triples for that one. There would have not been a percent, because there's no 1 plus or 1 minus for that. So that one triples. Is that one going to be going up or going down? Up. Okay? That one's going to be going up. All right, Chase. What's my starting value on this one? 8. Jack, is this one increasing or decreasing? Decreasing. Hallie, by what percent? Bless you. All right, Jeremy, what's my starting value on G? 100. Stephen A., is it increasing or decreasing? Increasing. All right, this one, when you do 1 minus 1.5, what's the calculator give you? What's the calculator when you do that? 0.5. What is that as a percent? What? 50. Very good, Elijah. How many times do you have to move the decimal? You always move it twice. So if you move the decimal twice, it turns into 50. Turns into 50%. Okay? All right, and the last one, H. Zach, what's my starting value? 50. Brandon, increasing or decreasing? And Madison, what percent? Confidence, 89%. Okay. All right, any questions on those? Okay, last 1, 2, 3. Last 3. All right, the change of a quantity after x years can be modeled by the function y equals 200.96 to the x, which describes how the quantity changes over time. Okay, everybody circle the y equals for me. Circle the y equals. Before we read the answer choices, let's label what we know. What do I know about the 200? It's the starting value, so I'm going to put that. It'll take me 1 second. What do I know about 0.96? Is that increasing or decreasing? So I put a down arrow. Takes me 1 more second. And then I go ahead and put that in my calculator. 1 minus 0.96. 1 minus 0.96. What does it give you? 4%. So I go ahead and label everything I know. Okay, A says it is growing at 0.96%. Is this growing? No, it's decreasing. So that doesn't work, and it doesn't have the right percentage. B says it's growing at 96%. Yes or no? No, why not? All right, good. C, it's decreasing by 8 each year. It's decreasing. Is that what we put it was decreasing? At an annual rate of 4%. So D is the answer to that one. Number 10, the function P of T equals 52, 1.025 to the T models the population growth of a town and thousands of people T years after 2010, which best describes the population growth. All right, guys, so help me label it. Riley K, what would be my starting value? Guys, go ahead and label for me. Label, label, label. Stephen A, what else do you know about that? Increasing or decreasing? Good, so I'm going to put an up arrow. I know it's increasing. And Chase, what would be the percentage? Very good, 2.5%. 2.5%. All right, Shakira, give me an answer choice that I can mark out. A, why? It's the wrong percent. That one has 102.5, so we can mark out A. Hallie, what's another answer choice you can mark out? B, same reason, doesn't have the right percent. Jack, what's the only difference between C and D? Very good. 2010 or 2011, guys? Go back and read the problem. What does it say in the problem? Yes, but. 52 is my starting value. So it's going to start in 2010. And then the population growth happens after that. But it starts at 2010. Does that make sense? Okay. Other questions on that one? All right. And number 11, what does the value of 2 represent in the following function? Y equals 60, parentheses 2 to the x power, where x is the time in years. All right, guys, is the 2 my starting value? No. What's my starting value? 60. So you can mark out A. It doesn't start at 2. Increases by 2. In math, increases means to do what? Add. Are we adding 2? No. C says the function increases by 2%. If there's a percent, they would have had to put what extra number? For a percent, think back to earlier today. A 1 plus 0.02. Is that what's right there? No. What does doubles mean to do? Multiply by 2. Is that what they're doing? Yes. So it's D. Okay. Any questions on those? All right. OYO time.